Hello students, in this video I will go through the exercises out of Envision, page 283 to 284, which is also on squares and rhombus. Let's take a look. So question 1 reads, what properties of rhombus, rectangles, and squares differentiate them from other parallelograms? Well, the thing is, what this question is really asking for is to really list out the properties of rhombus, rectangles, and squares. So a rhombus is a parallelogram such that the diagonals are perpendicular bisectors of one another. And actually, if they are perpendicular bisectors of one another, then what will happen is all four sides are going to be the same. A rectangle, or actually, let me talk about a square first. A square is also a rhombus. So if it's a rhombus, it is also inherently a parallelogram as well. But not only are the diagonals perpendicular bisectors of one another, they are also congruent. So if that's the case, then what will happen is all four angles are going to be 90 degrees, and all sides are going to be the same length. A rectangle shares some property similar to a square, such that the diagonals are congruent to one another. And because of this, a square is actually both a rectangle and a rhombus, because of the fact that they have that property, that a rectangle has its diagonals congruent. So a rectangle is a parallelogram where the diagonals are congruent and that there are at least one right angle. And with that, these are the three things, these are the properties that make those quadrilaterals different from that of a parallelogram. Okay, it's more specific kind of parallelogram, if you will. All right, question 2, error analysis. Figure QRST is a rectangle. Ramona wants to show that the four interior triangles are congruent. What is Ramona's error? So it says QRST is a rectangle. If that's the case, then that means these sides are the same. It also, and if this is a rectangle, then the opposite sides are congruent. Adjacent sides do not necessarily have to be the same length. And because of this, you can clearly see that they are going to end up being different triangles. We will have two pairs of congruent triangles, okay? So RP triangle RPS is going to be congruent to that of TPQ. And we can say that RPQ is going to be congruent to TPS. But we cannot say that all four of them are the same, because not all four of them, all four of them do not share a side-side-side congruence relationship. Only two pairs of them do. Diagonals of a rectangle are congruent and bisect each other. So RP is congruent to TP, is congruent to QP, is congruent to SP. That is true because the diagonals are perpendicular bisectors. Okay, so I went a little ahead of myself there. So this is actually Ramona's explanation, so my apologies there. So Ramona's explanation is this, right? That the diagonals, because the diagonals are perpendicular bisectors, we know for a fact that this is not true. Okay? Diagonals are not perpendicular bisectors in a rectangle. So diagonals do not have to be perpendicular in a rectangle. They must, however, be congruent to one another, but they do not have to be perpendicular. Let's take a look at the next one. Find each length and angle measure for rhombus DEFG round to the nearest tenth. DEFG is a rhombus. Okay, and we're asked to find out what DF is. So DF is the diagonal. So if half the diagonal is 5, DF therefore must be 10. Because this guy here is 5. We're asked to find out what DFG is. DFG is this angle over here. So this angle over there is going to be the same as that angle there, and this must be a 90-degree angle because this is a rhombus. So therefore, the leftover angle here must be 28 degrees, and if that's 28 degrees, then DFG must also be 28 degrees. And then we're asked to find out what EG is. So to find out what EG is, that's this side right here. Since I know since I know one of the sides is 5.6 and one of the other side there is 5, I can use the Pythagorean Theorem to find out half of EG. So I say, I'm going to call this side here x. X squared plus 5 squared is equal to 5.6 squared. I will now apply the Pythagorean Theorem and solve for x. So 5.6 squared minus 25. That's just going to be a little... It's going to be not much at all. So let me see here. 5.6 squared minus 5 squared. What is that? That's 6.36. And then I'm going to take the square root. That's 2.52. So x is equal to 2.52. And since x is equal to 2.52, EG is going to be 2 times that. So that will be 5.04. Okay. Find each length for rectangle MNPQ round to the nearest tenth. So you're told that PQ is equal to 4. And this is a rectangle. So that means all of these will have a measure of 5. And that will be 4. We don't know what this is. Okay, but so let's see here. MP therefore must equal to 10. MQ, MQ, well, since we know that this is a rectangle, that means that must be a right angle there. And if that's a right angle, then MQ, I'm going to call that x, can be found by using the Pythagorean Theorem. X squared plus 4 squared is equal to 10 squared. Subtract both sides by 4 squared. I end up with 100 minus 16, which is equal to 84. And then, therefore, x is equal to square root 84. And can that be reduced? 84 is divisible by 7. 7 times 12 is 84. So 4 is divisible into 84. So that means MQ is equal to 2 square root of 21. Okay. Find each length and angle measure for square WXYZ. So WXYZ, if I'm told one of the half diagonal there is 7, so that means PX is equal to 7. WP is equal to 7, and PY is equal to 7. And YPZ here has to be a 90-degree angle because a square is a rhombus and diagonals are perpendicular bisectors of one another. XWP has to be 45. And then I need to find out what XZ is. XZ is equal to 14. Okay. What is the value of x in the accompanying diagram there? So since this is a rhombus, this angle over here should also be 4x plus 5. And this angle over here should also be 4x plus 5. So that means 2 times 4x plus 5 plus 8x minus 6 should equal to 180. If I combine like terms, I end up with 8x plus 10 plus 8x minus 6 is equal to 180. 16x plus 4 is equal to 180. Minus 4 from both sides. 16x is equal to 176. Divide both sides by 16. What is that? That's 11. So x is equal to 11. All right, moving on. Exercise 18 to 20, find each angle measure for rhombus ABCD. So ABCD is a rhombus, and I know that this will be a 90-degree angle. And since this is 4x minus 3, this angle over here must also be 4x minus 3. So therefore I can say that 4x minus 3 plus 7x minus 6 is equal to 90 degrees. I know I'm going a little out of order here, but 7x plus 4x is 11x. Negative 3 and negative 6 makes negative 9. Add 9, 11x is equal to 99. X is equal to 9. All right, so now let's really answer the question. ACD is this angle over here. So I want to take 9 and plug it back into that. That's 7 times 9, that's 63. 63 minus 6 is 57. So that means ACD is equal to 57. Angle BAC is going to be the same thing. That's also 57. BEA, it has to be 90 degrees because this is a rhombus. Diagonals intersect perpendicular. They are perpendicular bisectors of each other. Question 21. Find each length for rhombus PQRS. Round to the nearest tenth. 21 is this is a rhombus, and if that's the case, then that means 2x plus 2 is also going to be on the other side. And this is going to be 90 degrees. 4x minus 7 will therefore equal to 2x minus 1, because QT will equal to TS. QT is equal to TS. So now I'm going to solve for x, subtract both sides by 2x, I end up with 2x. Add 7 to both sides, I end up with 6. Divide by 2, I end up with x is equal to 3. Since x is equal to 3, this will equal to 4 times 3 is 12. 12 minus 7 is 5. These will be 5 apiece. And then PT here will equal to 2 times 3 plus 2, that's 8. Okay, so TR, therefore, must also equal to 8 because TR is equal to PT. QS is the entire length, is going to be double QT, which is going to be 10. And PS, well, since I know this is going to be a Pythagorean Theorem problem, PT is 8, TS is 5. So that means PS, which is this guy right there, I want to call x squared minus is equal to 5 squared plus 8 squared. So this will be 25 plus 64. Add them together, I get 99. I'm sorry, I don't get 99. I get 89 is equal to x squared. So that means x is equal to square root of 89. And is that divisible by anything? Doesn't appear to be so. Right. So PS is equal to square root of 89. Okay, moving on. This is a rectangle. GHJK is a rectangle. GHJK is a rectangle. If that's the case, then that means this angle over here is 52. That means this angle over here is 38. This is 38. This is 52. This is 38. And this angle on the inside there, that's 104, so that's 76. And this is 76. And that means this angle over here is 104 and 104. And this is 10, and then this is 7. And of course, this is 52 and 38. Okay, so let's find out what GHK is. GHK has to equal to 38. HLJ is equal to 76. Whoops. Is equal to 76. GJ is going to be the Pythagorean Theorem, right? So it's 10 squared plus 7 squared is equal to GJ squared. So that's 149, or square root of 149. And what is HL? HL, therefore, will be half of that. Because diagonals in a rectangle are congruent, and diagonals bisect one another. All right, last problem set of this assignment. I'm told that QRST is a square. SV, actually no, find each length and value QRST round to. So I'm told one of the side length is 4. So that means the diagonal RT is equal to 4 squared plus 4 squared square root. And if you work this out, this becomes square root of 32, which is 4 square root of 2. And since I'm asked to find out what SV is going to be half of that. SV is going to be half of that. So that means this is going to be 2 square root of 2, because it's half of 4 square root of 2. RT is going to be 4 square root of 2. And what is the perimeter of RVS? RVS will be, well, since RV and VS are this are the same length, 2 square root of 2, it's 2 square root of 2 plus 2 square root of 2 plus 4, which then becomes 4 square root of 2 plus 4. That right there, ladies and gentlemen, is the perimeter of RVS. And I think that's it.